Hi, my name is Gregory. This is my solution to the bounded buffer problem in project number 2. And so in the first implementation, we were not to use semaphores and we want to detect a race condition. And so I have a buffer array initialized and the appropriate properties and variables. And we create two threads. One thread is for the producer and one thread is for the consumer. And these threads will run concurrently. So we'll go to the producer method. Essentially, we have a while loop, and for each loop, we initialize a k1 variable to a random number, and then we loop from 0 to k minus 1. And for each buffer slot visited, we want to write a 1 or add a 1 to that buffer slot. So if the slot contains a 0, adding 1 will equal 1. However, if it contains a 1 already, adding a 1 will equal 2, and at which point then a race condition has occurred. So after the for loop, we just go to the next variable in the slot buffer, and then we put this thread to sleep. And then going to the consumer function, we basically it's kind of similar, but at the beginning of this while loop, we put this thread to sleep because the producer always begins. And then we initialize a random k2 variable and we loop from 0 to k minus 2, and we have a data variable where we extract what is in the buffer slot and we compare it. So if the data is greater than 1, then we know that a race condition occurred where the consumer was too slow and the producer was producing too fast, or if the data equals 0, then a race condition was detected where the producer was too slow, or else everything functioned as expected, and then the consumer just reads the data and changes or writes a 0 in that slot. So we'll go ahead and run this code. Okay, so we have a race condition detected here where the producer was too slow. We want to run it one more time. Okay, producer was too slow one more time, and that'll be all. See if we can get a consumer was too slow, or once again, the producer was too slow on these 3 attempts. So we'll go over to version 2 with the implementation using semaphores. So once again, we have the buffer array initialized and the appropriate data variables. And we have 3 semaphores here that were utilized. The empty semaphore tells how many slots are empty. Full semaphore tells how many slots are full. And then mutex, a mutual exclusion semaphore, which means that only one method, producer or consumer, can enter the critical section at a time. So the two thread or the thread creation process is exactly the same. So in the producer method, so we have a for loop that loops through the number of rounds or until is done becomes true. And so once again, we initialize the K1 variable and then we loop through it and we write our data. However, in this time, we do an empty dot acquire, wait for an empty slot. If one is not available, then this process will block. And then we do a mute. After that, we do a mutex acquire. And once again, if there's no permit available, then this process will block. However, if it's not blocked, then we just write a 1 into that buffer slot and print out some information. And then we go to the next slot in the buffer. And then we are able to release the mutex and then release a permit to the full semaphore. And then in the outer for loop, we put this thread to sleep. And after the for loop here, we change is down to true. And so here we go to the consumer method. Once again, we have a while loop, and then we have a K2 variable again, where we initialize to a random number, and we put this thread to sleep because the producer always begins. And then we have a for loop, inner for loop here, and once again, we do the same thing. We try to acquire a permit from the full semaphore and then the mutex semaphore. Once again, they will block if there's no permits available. And then we once again compare the data from the buffer slot. However, this doesn't really apply because there will not be any race conditions detected because of the use of semaphores. And then, so after that, the consumer has read the slot. Then the consumer changes that buffer slot back to 0, and then we print out a message again, and then we the mutex, release a mutex permit and an empty permit. And we also have a helper function that just prints out the buffer as well. So let's go ahead and run this version and see what it does. Oh, okay, that's the correct one. Here we go. And so if you can see, it starts with the producer. I don't want to go all the way right into the buffer. It wrote 3 ones, and then the consumer read the first one, and then the consumer read the second one, and then the consumer read the third one. So here we basically start over, and then the producer starts from the third index and writes a one and so forth, and then so it just follows this pattern all the way to the bottom, and then at the end the producer finishes writing its ones, and then the consumer reads those final 2 ones here, and that is my solution.